It's wonderful that you made it to this point. This is our last class for instrumentation. So right now we are going to be doing neuro, cardiovascular, and robotics. And I'm going to teach you how to do your rapping. But first, before we do that, I wanted to go over a neuro. And you'll see this in your catalog that's on your in your lecture notes. That's on your PDF. This is called a kerosene. And the kerosene, you have to actually use a postcard or an index card to see if it's sharp. It's not like the scissors. Also, you bring your kerosene up to your light, and if you look through, you'll see if you see bone. It's very important that you look at your kerosenes and make sure they're clean, because when this kerosene is used to clip bone, so it's basically you're just clipping the bone, and bone gets stuck inside the shaft, unless it can come apart during decontamination. This one cannot. This one is a gold number 2 kerosene, and the kerosenes come with different sizes, and you can tell the sizes from the jar. But this is a number 2. They also come at 3, 5, 4, and 1. But this one is actually a number 2. And this is used for spinal surgeries. If you remember the anatomy, look at the spine, usually they use this to clip the side of the spine, which is the spinous processes. And the spinous processes can lean on or squeeze onto the nerve. And if that's the case, like if there's a slip disc, they can actually take this kerosene and break apart pieces of the bone that's leaning on that nerve. So this is a kerosene. This is a bipolar forceps, and this bipolar forceps is, you will always see these in neural trays. This is used with like a cautery. So it's attached to a machine. That's why you see the 2 prongs. So it's attached to a machine, and these areas, they actually cauterize blood vessels. So if there's extra bleeding and you got to get into the nerves, you could cauterize it so that it doesn't bleed over the nerve as the neurosurgeon is working on the nerve. And if you look at my hand, and I'm a little dark in here, but if I could trace my veins and arteries. First of all, the veins sit on top. So this is what you see when you're looking at your hands and your arms, is your vein. Your artery sits underneath the vein, and the nerve sits a little bit towards, like this would be right here, would be your nerve. So you will have to cauterize the artery, because they actually don't want to cut the artery, because the artery sends blood to the heart, away from the heart, and the vein sends blood to the heart. So this is why when you get a blood test and you get needle in your vein, it doesn't spread out or sprue out like you would if it's an artery. When they're doing blood gas, they usually go with the blood gas, and again, it's underneath the vein. And when they do a blood gas, and believe me, that hurts a lot, because you have to go into the into the artery, and then pull the blood out into the test tube. But that's if you're doing phlebotomy. That's the neuro. Now, the cardiovascular, I'm not going to really go over the cardiovascular, but I will show you a cardiovascular tray for time's sake. This is the cardiovascular tray, and this tray is called open heart retractor. Some places may have CVOR retractor. Some places may just have heart retractor. Nevertheless, this is a heart. This is a tray, and you always have towel clamps. Towel clamps are always, these are towel clamps. They're always in your CVOR tray. You always have a You always will have these rack in the tray. That's always going to be in the tray. You have a pin cutter, so you can cut wire. That's always in your tray. And this is also another wire cutter. These are wire cutters here. But I'm going to show you a vascular. So when you say a cardiovascular, that means they're working on the vascular, which is the arteries, the veins, and the capillaries. But most of the time, when you do vascular, you're doing the aorta. And you will see like an aorta aneurysm, because usually when you have blood clots, well, let's call it thrombosis, it travels, and it can travel and block the abdomen, it can block the heart. So this is very important when a person needs open heart surgery. These large instruments here, when they need open heart surgery, this is very important to grasp the larger vessels that's in the body. This particular instrument is called a Statinsky. You will always see a Statinsky in a CVOR all the time. And the Statinskys look like a DeBakey. And if you look inside, and when I showed you the DeBakey from the other tray, that's what it looks like. If everybody could see that. So this is called a Statinsky. This is a rib retractor. So basically, it says what it is. It's the doctor put it in and open up the rib cage. The rib cage, it has to be broken open in order to see the heart, because the heart sits behind the rib cage as so. And your heart is about as big as your fist, no matter who it is, male, female. But when you're processing this retractor, it's very important to put this knob behind the blade. It always go behind the blade, always. If you put it in front of the blade, this is wrong. If you put it in front of the blade as such, and the doctor cannot get to the blade as such to open up the chest. And believe me, some people have done the mistake as like this, and you have surgeons that are the nastiest things alive. They will take this and throw it across the floor and beg for another one and say, whoever put this tray together, have them fired. So, with that being said, and I'm not trying to scare anyone, but it is what it is. This is a good profession, but you're dealing with people. And if you do your job like you're on the table. You want everything to be correct. You want everything to be working properly. You want your instruments to be working and not stuck where they can't open it, because it's very critical for the heart. And this is how you put together this retractor. It's always behind the blade, no matter what it looks like. Always behind the blade. So when the doctor put it in the chest, he can close it however he wants. He can open it, but it's always behind the blade. Always behind the blade. Okay, so I also gave you a catalog for robotics. I can't really show you exactly what a robotics does. Only thing I can show you what the arm looks like. Each arm have different levels. This one actually is a large needle driver. So basically, it's a surgery, and I said put it in your PDF. The different surgeries that's used with robotics. For example, GYN, general laparoscopic, and anything dealing with the heart, anything that the body, that it can go inside the body, that this can be used. when you're processing these these arms, there's a white, like a little white dot. This is like a sensor, and when it's red, it's white right now, so that means this arm is good. This arm is operable. You know, they can operate with it. If this was red, this has to be thrown away, because that means it's no good. So what happens is the arm, I'm gonna just kind of show you this conventionally. Here's a machine, and the arm sits inside the machine as such. When the arm goes in the machine picks up this sensor right here. So if the machine picking up the sensor and it's white, that means it's good to go. If the machine picks it up and it's red, the machine will not operate. So what happens is they put the arm in the socket as such, and you have several, and you'll see that on in your catalog. You have several arms that hang down like this, and you put it in. So you have a needle driver, which is like a needle holder. You have scissors, you have graspers. So they are put in as such. And the doctor puts his head in a machine, and this is the robot. The robot actually does the job according to what the doctor pressed. And he can look on the screen and see how it's going inside your body. But to process this, you have to make sure that there's no bioburden here. You have to make sure that all the mechanisms work. And that's our job. Our job is to make sure that everything is working. Make sure there's no extra fluid. You can use these actually, and if you use these knobs here that turn, you can actually see how it's turning. See that it's turning it. So then you say, okay, this is working. Even though it's white, you still do the same thing, because we're talking about machines, and machines can break down even if it's good. Okay, so the last thing I'm going to show you is how to do wrapping. Okay, instrument. And I already processed this. Remember to put in your covers here. You make sure you put in your chemical indicators, your CIs. And here's your count sheet. Remember I was telling you about the count sheet? You must always have a count sheet inside your trays. However, I'm not going to put it inside the actual tray because we're wrapping it. I'm going to actually put it on top, and I'm going to wrap it something like a Christmas present. But it's a little different. Sizes. And you must take the size and match it to what you're wrapping. So for example, if I have something like this to wrap, I'm not going to wrap it in this big one because it's too big and too bulky. So you have to estimate. Sometimes you have to take one or two wraps to estimate it. Now this wrap is a continual wrap. That's in our that's in your lecture. This is the double wrap. They're double side. All right. Now, when you do your assignment, I want to see a video of you doing this. It doesn't have to be as perfect as maybe I would do it, but I just want to see you can use Christmas paper wrapping, and you can just get like say a box of cereal or something. But I just want to see that you see the concept of it. We're gonna go slow. Okay, so I'm gonna actually put it in the middle, and then you has to be triangle to triangle. Triangle to triangle. It must be even, if you can see that. Okay, so everybody has different techniques. My technique is I want it to be neat, because when you do your wrapping and it goes into the OR, all they need to do is flip it off, flip it up to open it. They don't have time to sit and open that because it's a sterile feel. So I'm going to show you exactly what I'm talking about. Okay, so I normally tuck under, and see that's neat. Make sure that it's neat and tight. So it's just like doing a wrapping. I actually pull down my sides, bring it over, slide it over, and make it neat. And this is the tape I was telling you about. This tape actually has the white lines to let the person know that this has been sterile. So I'm going to actually tape it so it can stay. Some people hold it and go on, but me personally, I just like to tape it so then I know it stays. I'm going to same thing. Once do one side, I'm going to do the other side. The point is making it neat. So as you can see, it's a triangle here. Then I'm going to actually tuck in. Everything is supposed to be neat. So I'm going to tuck in my sides, and I still have my triangle, and it's tight. I'm going to tuck in my sides, and it's okay to leave a little lip. And the reason why you leave a little lip because the OR personnel just lift it up. So once I leave a little lip, so I put my tape over it, and it's very important that you put your tape, and it's very important that it's tight. Hopefully that's not too fast for you because I kind of go fast. So once you do that, it's important to keep your tags. So you're going to put your tags on, and that lets the person that's sterilizing know what they're sterilizing. And also let the OR know what they are using. And also let the person that's doing the case cards know what instruments they need. So let's say if the person needs the liposuction. If there's nothing on here, how would they know what it is? So you gotta have your labels. So when you're doing your wrapping, I don't want you to do it exactly the way I did it. I just wanted you to see the concept. I want the triangle concept. All right, well, that ends your instrumentation. Our next feat will be sterilization, and have a great day.